Example 1 here on the normal distribution hypothesis test is taking a look at multiple observations. So here an office water cooler is said by the manufacturers to dispense an average of 250 milliliters of water. Okay, so this is with each use, and it has a standard deviation of 5 milliliters. Jordan suspects the manufacturer's claim is too high, and he observes this following sample here. So this is for 5 days, and these are the measurements or the amounts dispensed. So here, this is a hypothesis test, so first what we want to do is define our hypotheses. But before we define the hypotheses here, we need to define the parameter. So mu here is the parameter we use because this is a normal distribution hypothesis test. So mu is the mean amount. So mu is the mean amount the water cooler dispenses in each use. So mu is the mean amount. So let's write this out in full. Dispenses in each use. Okay. So in that case, we can now define our hypotheses, our H0 and H1 here. And in this case, H0 will simply be mu here is equal to the value that we're given for the average here, which is the manufacturer's claim of 250 milliliters. So that's 250. And then H1 here. Well, in this case, first we need to decide if this is a one-tailed test or a two-tailed test. Well, here Jordan suspects the manufacturer's claim is too high. So what we're going to test here is that mu is actually less than this. If we're saying it's too high, then we're suspecting that it's less than 250. Okay, so mu is less than 250. Now let's define the test statistic. So the test statistic here, if we write this out in full, well, this is x bar, and that's the mean of the 5 observations. So this is the mean of the 5 observations. Okay, so we write that in full. So now let's define our distribution here. In this case, we know the mean here, or x bar, is simply going to be here a normal distribution. It's a normal distribution hypothesis test. The mean amount is what we're given here, 250. But we have to be slightly careful in regards to the standard deviation here. Remember, when we're counting here for x bar, we do the standard deviation squared. So this is going to be the variance here. So it's the standard deviation squared, 5 squared, and we divide it by the sample size, 5. Okay, so that's our variance there. And obviously, 5 squared is 25 divided by 5. We simply get x bar is a normal distribution with mean 250 and variance 5 there. Okay. We know the significance level. We're given that in the question, and that's 5% there. So alpha here, the significance level, is 0.05. So here, all we need to finally do now is calculate the mean of the samples here, our test statistic. So therefore, x bar is equal to a fifth of the sum of these samples here. So 240 plus 235 plus 250 plus 245 plus 230. Okay. So in that case, if you work this out correctly, what you should get here is 240. And now finally, what we want to do now is test this evidence here. So this is going to be now the probability. And again, using our hypotheses to decide the inequality here, this is x bar being less than or equal to the evidence of 240. And here, just use your calculator to calculate this probability. And what we actually get here is a very, very small probability. We get 3.872 times 10 to the minus 6 here. Okay. And this is less than the significance level here. This is less than 0.05 here. So in that case, we're going to reject H0 here. Okay. So if we just finish here with our conclusion at the very top, and let's get that in blue then. So here we reject H0. So we reject H0. And what we say then is there is sufficient evidence. So there is sufficient evidence sufficient evidence here to suggest the manufacturer is not correct. Is not correct. Okay. And that gives us our solution there to example 1.